So 7.4, okay. And what are we trying to do? We're trying to find key features of graphs from the equation. Okay. And then drawing your graph. And then, so basically that's part one. So this is essentially what we're doing first, is drawing our equations. And then part two, matching graphs to the equation. So finding equations from graphs. So part one is you have an equation and you're trying to graph it. And part two is you have a graph and you're trying to find the equation, okay? So here we are looking at A. So I will be trying to go back over some of the information, the formulas and so on. So basically, we have three formats for our quadratics, all right? And this one, if I look at it, so I'm looking here at the equation, and what I see is a square, a variable squared, x squared, and I see an x, and there are no parentheses. And essentially, that would be then the ax squared plus bx plus c pattern, which is my standard form. So then if I don't see a number in front of the x squared, the number is 1. So a is 1. B is the number in front of the x, which is -3. C is the number that's by itself, so C is -4. So the first part is we should be able to find that information based on essentially the format, and all we're always looking for is the number values, okay? So not x. X is your variable, x is not a parameter. Okay, so A is positive, which means my graph is happy, so it goes up, okay? You can draw it or you can write the word up. Either way is fine. Basically, I usually draw it because that helps me figure out what I'm doing, okay? From here, we are supposed to be finding some other information, but I don't necessarily want to find it in the order they've specified. I am actually going to want to start on 7 and 8. So I'm going to start here because essentially that is finding the key point of my parabola, which is my vertex point, okay? For a standard set, you have a formula that applies for your axis. So your formula for your axis of symmetry is x equals -b over 2a. Again, and so what does that mean? We have to use this information. So this is really important. We find our parameters and then essentially we put them in to the equation to find the vertex point, okay? So let's look at B. What I see is -3. But what I'm noticing is this says, hey, it's already negative. So negative of a negative turns is positive, okay? Whatever the B value is, in here, it's essentially opposite, okay? And then 2, and then essentially 1, okay? Generally for input, if it's not already in a set of parentheses, you should put parentheses around it, okay? So what I get here is 3 over 2. So this equals 3 over 2. So my axis of symmetry, I'm going to write it as 1.5. Okay, so that's the x-axis of symmetry. What that means then is if you go to a graph set, okay? So if you don't have this printed, then draw a quick graph. What you want to do, label it, essentially at least 1 through 5. But what I have here is 1.5. And what that means is this is my axis, and my parabola will be centered around the line 1.5, okay? So I'm locating where my parabola is located, where it is on the graph, essentially. So what's the next part of this? Okay, I need the actual point. All points are x, y. All points have an x coordinate and the y coordinate, because if all I have is an x coordinate, what I get is essentially an entire line, like the axis line. So I need to find the y coordinate. The y coordinate is going to take the value I know, x equals 0, and what I want to do is put it into my equation. So where does it go? Into the equation for y. So you pick your x, or you find an x you want to try for, and then you want to put it into the y equation, okay? So my y equation is y equals, oh wait, not 0, what am I doing? Sorry, error, 1.5, okay? Y equals 1.5 squared minus 3 times 1.5 minus 4. Where did that information come from? Is essentially, here is my equation, and then where is it coming from? I'm basically using that formula. So this is my formula for my y coordinates with a variable and unknown variable x. Okay, so right now I have x is 1.5. So what am I doing? I'm taking that x, I'm putting it into the equation. All right. This particular one obviously it's kind of hard to evaluate because the 1.5. So what I want to use is this very awesome tool called the calculator. And on my calculator, I want to feed it in exactly as what you see on the screen with the parentheses and everything, okay? So when I do that, okay, I would actually like you guys to do that right now, and you can chat me with like what you got on your calculator. So find a calculator, or if you don't have one, then I guess you'll have to just watch this. But I would like to see what you're getting for your answers. So I'd like a few answers here, at least a couple. Okay. All right, so I got a couple of answers, and yes, those are correct. Negative 6.25. All right, so this would essentially be the work I would want to see. Okay, notice I'm not doing any more work because I put it in my calculator to show me. So what is my vertex point? It's 1.5, negative 6.25. Okay. So star in my points, 1.5. So this is the table that you're creating of your value set. And I'm putting this one in the middle because it's the middle point of my parabola. It's the vertex. You can essentially put this where you want. So if you want to put it on the top, then go ahead. But I do want to see that you have identified it. So you've got a star, you've got a box, you've got something that identifies that this is the important point, okay? So 1.5, negative 6.25. So it's going to be right there somewhere. The graph is small, so it's hard to show exactly where the point is, but that's close enough for graphing purposes. So it's right there, and then I know my graph goes up. So what I want to do next is find another couple points. So the point I'm going to look for next is the y-intercept. Okay, y-intercept says that x has to be 0. So essentially y-intercept is a point where I have 0 and I don't know. So 0 and something, okay? So what do? I picked x equals 0. Then what? I put it into my same exact equation. y equals 0 squared minus 3 times 0 minus 4. So x is 0, put it into my equation, and I evaluate it, okay? Y-intercept is always usually fairly easy to find because 0 just kind of goes away. So what happens here is that 0 squared is 0. 0 times 0 is 0. 3 times 0 is 0, which leaves me my only actual value here as -4. So my other value for that is -4. Okay, so I have found the y-intercept point, and essentially my y-intercept point is right here. So basically y-intercept work, y-intercept, okay? So I put that in my graph. 0 and 4. 0, wait, oops, typo. Okay, I'm looking at it, 0 and 4 is up here, but I'm looking at that, and that looks really far away. So pretty confident I made a mistake. So I check, okay, so I'm checking again, and I'm noticing, oh yeah, it's supposed to be -4. So that looks a lot better, -4. Okay, so since I have point on, essentially what I've got now is a point, and it's over here on the left. So this point is on the left of the vertex. So there's the vertex, there's my point. There should also be a matching point, essentially, there should be a matching point like here, okay? So your check to make sure everything is going well is that you should find this matching point, all right? And what you do is it should line up on there. So here I am, 1.5, and that's at 0. So that's 1.5 on the left. So if I go 1.5 on the right, looks like I should be at 3. So I'm going to check for 3 and see what happens. So what am I doing? I'm choosing x to be 3. I plug it into my value set using parentheses. So everywhere there was an x in the equation, it replaces with 3. And I get 9 minus 9 minus 4. Huh, interesting. So 9 minus 9 is 0. And the only thing I have left is -4. So that turns out correctly, which it should, because if I did everything right, it should match. Because that is one of the ways you check your parabola is you have matched points, okay? So that looks pretty good so far. Actually, if all I asked you to do is graph it, this would be enough to graph my parabola because I could pretty much draw a pretty decent parabola with these 3 points. Like it's got to go something like that. All right. However, this problem is asking us to find 2 other things, which are the zeros and the x-intercepts. These are essentially the same pieces of information. It's just how do you write it, okay? So zeros are where you set your equation. So your equation equal to 0. So zeros are where you solve your equation for 0, okay? That's what zeros are. So if I'm going down here, let's say this was vertex work here, okay? So that's vertex work. All that, okay? And basically saying my equation set. So what is my equation? My equation is x squared minus 3x minus 4. Where did I get that from? It's basically from that equation that was up there, okay? If you're writing this on paper, you should have that written down, okay, because that's your main equation. So minimally, you need to have that on your paper because that's what I'm using for my source. So that's my equation. What do? I set it equal to 0, okay? Then I solve it. Well, how do you solve a quadratic equal to 0? Your first step, if you can, is factoring. I will let you know, if you cannot factor these, then do not worry about the x-intercepts and so on, because those are then quadratic formula points and they are a mess. So here we are, and I can factor that. It actually does factor into x minus 4 and x plus 1 equal to 0. So now I'm just solving using the factoring rules. So factoring rules says take each factor. So first factor, x minus 4. Okay, so that's my first. And what do? It's equal to 0, and then you solve it. So x has to be 4 for your first solution. Take your second factor, which is x plus 1. Set it equal to 0. X is then -1. So that's what I'm doing second. And then that's my second solution, okay? Remembering that usually quadratics have 2 solutions. So when I have 2 numbers multiplied, remember this is this number, x minus 4, times this number, x plus 1. Well, if one of those numbers is 0, then 0 times anything is 0, okay? So if this number is 0, 0 times that number is again 0, okay? So that's what I'm doing, because essentially, if I say x is 4 and I put 4 minus 4, hey, 0, 0 times any number is 0. So 0 is the only number that works that way, so that's why you can solve for factors directly, because essentially you're just saying they're equal to 0, okay? So these are the values that are the zeros. So up here what I have is x equals 4 and x equals -1, okay? Then those are also essentially the x-intercepts, because remember, what I'm remembering is this is essentially my y value. So what I'm saying is this is a point, and the first point is x is 4 and y is 0. The second point, x is -1, y is 0. Okay, what's important here? There's your solution, there's your x value. There's your second solution, there's your x value. Okay. So that's how the x-intercepts and the zeros connect. So zeros, x-intercepts, they are exactly the same data set, just one is the solution number and the other one is the points you put on the graph. So this one has a solution set of 4 and -1, zeros of 4 and -1, x-intercepts of 4, 0, and -1, 0. So 4, 0, 1, 2, 3, 4, and -1, 0. You can see on my original possible graph, I wasn't quite perfect on where it crossed the x-axis, okay? Because I hadn't found those points. Obviously, the more points you find, the more accurate your graph will be. So here I go. And there's my first graph, okay? And I found all the values I've needed to find. So there's 4, 0, -1, 0. I build my table. Maybe I put a box around this number because that's the center point, whatever. So I build my tables so the vertex is in the middle, and then I do kind of up. So I go up for one set of points and down for the other set of points. But you could also maybe pair them up. It really is your choice, but basically this table should show the points that are on the graph. Okay, so there's your table, there's your graph. Okay, these are the x points we have. So we have those x points from whatever method we chose to find them, or even we just picked them. And then these are the y values that we found by using the equation. Okay, so that's essentially the process. Each type of equation has some different stuff we have to do. All right. If anyone has a question on this first one, like you would like a little bit more explanation or something was unclear, I'm going to leave it there for just a second. If somebody needs to feel like they're finishing up that graph, okay. And we'll just pause for 1 second here. If you have a question, please ask. Yeah, let's go, I'll go back over that. So solving for the zeros. All right, so here we are. Let me just erase that and I'll just redo it. Maybe it would be more clear if I do it right here. Okay, so here's my set. Okay, what I'm doing is setting my equation equal to 0. Okay, so where am I getting the equation from? Essentially, it's the original equation. So right there. Okay, so I take that equation, x squared minus 3x minus 4, and I set it equal to 0. So your choices from here are essentially quadratic formula or factoring. So you can crunch these answers using the quadratic formula, but if you can factor, that's easier, okay? So without going back over how to factor, I'm just going to factor. So when I factor this set, I can turn it into two factors of x minus 4 and x plus 1 is equal to 0. So those are the factors that came from the original problem set. Now for your zeros. So now for my zeros, okay, basically what do? You take each factor. So there's my first factor, x minus 4, and I say let's solve that by itself. So there's my first factor equal to 0. I add 4 on both sides, I get x equals 4. So x equals 4 is the first solution, okay? Okay, that's factoring. If you need a factoring review, then we can talk about that a little bit later, but basically what I'm doing there, let me finish out the second one. X plus 1 equals 0, x equals -1, okay? So then I just generate my points. That's easy from there. What am I doing with factoring? You should have your whole factoring set going on here. So factoring. So there's my set. I draw my diamond. A is 1, AC is -4, B is -3. Two numbers that multiply to -4 and add to -3. Those two numbers are going to be -4 and 1. So times for here, check. Add for here, check. Then those are the numbers, since it's x squared, then x and x. So x squared splits into x and x. And then your numbers here, the -4 goes in for the -4, and the 1 goes in for the 1. Okay, so that was unit 5 and also unit 6. So I didn't do that step, but I kind of did it in my head essentially, but that's the factoring set. Okay, so I hope that answered your question. All right, so usually for zeros, you're going to need to factor unless you have another method. Okay, so the next form, B, the strategy is a little different for B. The reason why is because B is a different format. So if we're looking at B here now, all right, B is essentially vertex form. So vertex form is your multiplier A times a quantity x minus h, so times a quantity squared plus k. All right, so that is essentially vertex form. So A is -2, H, remember what you see is opposite, okay, so you might want to write a little thing, parentheses, opposite, so opposite for parentheses, all right? So H is -3, not +3, and then K is -2, all right? This particular one is, since A is negative, So that's an unhappy number. That means my parabola should go down. Okay. Once again, I'm going to start down here, axis of symmetry and vertex. All right, what is my axis of symmetry? What is my vertex? All right, because for vertex form, I mean, it's called vertex form. So vertex form, the vertex is actually your parameters. So your first parameter is h, the -3. So your axis of symmetry, x equals -3. And then your vertex is the -3 and then essentially the k. So for vertex form, your vertex is actually the hk point. Okay, so vertex form has the vertex inside it. So you don't really have to do much work there. All right, so I found the parameters and then the vertex is listed right there for me. So all I need to do is put it on my graph. So -3, 1, 2, 3. And -3, -2. So let's see, center point right here, -3, -2, vertex. And interestingly, I can see that this one actually goes down because A was negative. So that's not a very good sample graph, but that's what's going to look like. Gosh, it scared me. Okay, that's what's going to look like. And guess what? From looking at this graph, so this is the other reason why you find the vertex first, because now I know something. Okay, what do I know? Something about this stuff right here. Do I know something about any of this right now? Because it's going down from that vertex. If you think you know, put your answer in chat. Or you can unmute and just say it. All right. Feel like that question was confusing. Here's what I know. I drew my vertex. It's right here. I think about my graph. Okay. My graph. Yep, that's what we know. I think about my graph. My graph is doing that. Okay, so since my graph is going down from the vertex, I should be able to see just by thinking about it or drawing a possible shape for it that essentially I do not actually have any zeros or any x-intercepts. So we can write none. You can write D in E, does not exist. Why? So you need to say why. Because negative vertex and down, okay? That's essentially what I get from doing some upfront analysis. So that would be the reason how I know it, because when I'm looking at it, the graph goes down, so therefore it cannot cross the x-axis. That's just not possible for this particular graph, okay? If I chose not to do this step, this is why while I'm graphing, I try and use the graph to help me out a little bit. So if I didn't do that, okay? So if I'm like, okay, let's go on for what I can do. I can do this regular step where my equation equals 0. So I can do my regular idea where I take my equation, which is right here, right? Here's my equation. And I can set it equal to 0. So I can say, okay, if I'm solving this, I get negative 2 x plus 3 squared minus 2 equals 0. And then I continue solving it. So add the 2. Okay, divide by negative 2. I'm not going to write that step. I get x plus 3 squared equals negative 1. And then how do you get rid of a square? You square root. Okay, so what we see here is this turns into the square root of negative 1, and that is imaginary, right? So we could also say it doesn't exist because we got an I value, okay? So if you got an imaginary set, that means it's invisible and it doesn't work. So because our square root is negative here, because we have essentially this negative, that means it doesn't work. So if you chose to solve it, you can still see that it's not working, okay? It's just a little easier. I felt it's easier to look at the vertex first and then decide what's happening, because then you don't have to do that work, okay? If I've looked at it, essentially I don't really need to do this because I already know it's not there, all right? So that's that part. So the last thing I've got here is essentially I need my y-intercept. So for y-intercept, that means x. So for my y-intercept, that means x has to be 0. And what do? I put it into my equation. So y equals negative 2, 0, plus 3 squared minus 2. So that's what I'm evaluating. Okay, I need to remember that everything in parentheses should happen first. So all of this, and then the square should happen before anything else. Okay, squares are not regular numbers, they happen first. So 3 plus 0 is 3. 3 squared is 9, so I have negative 2 times 9 now, minus 2. So negative 18 minus 2. So I'm getting the point 0, negative 20. So I put in x as 0, and then my y-intercept's negative 20. Okay, I will let you know that many times, like I generally might not even choose to graph that point because it's kind of far away from my vertex point. So these are rather far apart, okay? But since they have that nice point for me, I'm going to put it on there. So let's see, I have 0, negative 20. If I can find a point on one side, I should be able to find the point on the other side. So what am I doing? I'm at 3 on my axis, so I went 1, 2, 3 to the right to get the 0. So negative 3, 1, 2, 3 to the left, I get negative 6. So I'm hoping that essentially that at negative 6, right there, right? Wait, 1, 2, 3, 4. Okay, so right there should be my matching point. So I'm going to choose negative 6 because I want to check to make sure it actually does what I expect it to do, okay? So y equals negative 2. What am I doing? I'm just putting it back into my equation. Only now, everywhere I saw an x, I changed that into negative 6. So negative 6. Then once again, I look at it. There's some parentheses. There's a square. Do that first. Negative 6 plus 3 is negative 3. Negative 3 times negative 3 is 9, okay? Notice we're moving kind of slow through this because we're trying to make sure we don't do anything stupid. It's really easy to make errors. There's a lot of numbers going on, okay? So you just want to be careful and avoid those errors. So -2 times 9 is -18, minus 2, and I can see that's going to check, and that is going to be the correct value of -20 here. So I can replace that point and say, okay, that's my actual point. All right. Am I too far over? 1, 2, 3. 1, 2, 3. I don't know why that doesn't look centered. It is centered, but I'm not seeing it right. Okay, so that's where I'm at. I didn't have x-intercepts. I should probably pick at least one more pair of points. Somewhere, probably in here somewhere, okay? So either -2 or -1, doesn't really matter. I'm gonna choose -1. So right here, I'm going to say x is -1, and what do? Same thing as always. I picked an x this time. I'm just picking it. Kind of close to the vertex, not too far away, hopefully. Y then equals -2. And what do? Everywhere there was an x, I put in a -1. So y equals -2, parentheses, -1 plus 3 squared minus 2. Again, anything in parentheses and squared, that has to happen first, okay? Parentheses always first, so -1 plus 3 is 2. 2 squared is 4, so -2 times 4, so that turns into 4, minus 2, that equals -8 minus 2, so I'm seeing -10 for my answer. So -1, -10. That looks about right. Okay, if I wanted to check the other side, I could. It's 2 units away, so 1, 2. That should be my matching point. I'm not going to check it, but that's where it should be. And then I should be able to draw my parabola fairly accurately going down. Okay, this one should appear a little bit stretched from before because of the multiplier of 2. So it should look a little bit skinnier than the original set. And then it's negative, so it's flipped. All right. Okay, does anyone have any questions on this one? Okay, I'm not seeing anything, so I feel like we're all right to move on. Okay, so we've done a standard set, we've done a vertex set, and then of course the last set is our factored set. So sets of parentheses. So what do we see on a factored set generally is an A value, x minus p, x minus q. And what do we remember? If we have parentheses, parentheses also always mean opposite. Okay, this form is factored. A is -1/4. P is -2. Notice that it's opposite in sign. Okay, Q is 6. Notice that it's positive. So when you're doing your format for these, they come in opposite, essentially because we're setting it up to be equal to 0 in the factors. So A is negative, that means unhappy, so it's down. All right. So unlike the other ones, because we're starting with the factors, I want to start with the zeros and the x-intercepts. The reason why is because how do we find the zeros and the x-intercepts? Is I take my equation, -1/4 x plus 2 x minus 6 equals to 0. What's your next step? Take each factor, equal it to 0. So first, -1/4 equals 0. Okay, I'm putting this on here specifically to show you that essentially that's just a number multiplier. So that is not actually one of the zeros. Okay, that's a number. 1/4 cannot be 0, so you should be able to tell that that's not possible. I cannot force 1/4 to be 0 ever. So x plus 2 equals 0. Should be able to see that that's x is -2. Last factor, x minus 6 equals 0. X equals 6. So if I put -2 or 6 into my original equation, I would get 0 for my answer. Okay, these are my x values. That means my x-intercepts are -2 and 0, because my answer was 0, and 6 and 0, because again, my answer was 0. So it's factored form. Start with the zeros and the x-intercepts, because they are definitely the easiest values to find. So now I'm going to put those points on my graph. So -2 and 0, 6 and 0. Okay, again, I'm leaving this space in the middle blank for my vertex, and I'm writing my paired set above it. So here's my pair of 0, 0, 0. So my pairs are going in up and above and below. Okay. All right, so that is my x-intercepts. Here's what I know. I know that if this is a parabola, and I know this parabola has to be going something like that, okay? So basically, my vertex has to be like in the middle, because otherwise, how can I get my parabola to go down, right? Correctly, because these 2 points, -2, 0, and 6, 0, are matched points, okay? So my vertex has to be in the center of those points. So basically, either by figuring out where that center is, or there's a formula that helps me figure out what that center is. So that's what I'm starting with is, okay, I know where the x-intercepts are, and I know that the vertex kind of has to be like centered in between those points. So what am I doing from here is I'm taking this information and I'm coming down to finding my axis of symmetry in my vertex, okay? So I take that information, and the formula here, it's different because I'm doing a different type. So I need the middle. So the middle value is going to be the 2 values, P plus Q, divided by 2. So essentially finding the average, okay? So P is -2 plus 6 over 2. So I get 4 over 2. So the axis of symmetry should be 2. All right. How do you find the vertex once you know that? Well, x has to be 2, put in. What am I putting it into? Obviously, still back up to my formula. So here's my formula that I'm using to calculate all my points. So there's my formula. Okay. What am I doing? I'm taking that formula. Y equals -1/4. And everywhere I have an x, I replace it with 2. So 2 plus 2, and then 2 minus 6. And then I just need to evaluate that, okay? So let's see what I've got. Equals -1/4. 2 plus 2 is 4. 2 minus 6 is -4. I multiply that. -1/4. 4 times -4, -16. Okay? From here, what I am noticing and realizing here is that you have a fraction bar, and that means division. So I'm basically saying I'm dividing by 4. So I'm taking 16 and I'm dividing by 4. Okay? I'm being formal about it, if I want to write it down, essentially what I have is negative 16 divided by negative 4. That's what I'm really doing. So negative 16 divided by negative 4 is 4. So my vertex point is 2, 4. So 2, 4, that's my star point. That's the middle. Okay, and then I can see that's right because if I look, here's my axis of symmetry at 2. And if I look to see where it is from here, if I count 1, 2, 3, 4, it's 4 units from the middle is 4 units to the right, and 1, 2, 3, 4, 4 units to the left. So the middle of my parabola has got to be equally distant. So 4 units from the first x-intercept and 4 units also from the second x-intercept because it's got to be in the middle. Okay. Again, that's probably enough to graph my graph because I've got 3 valid points. It will be going down. So if you look at your sample graph, essentially it's going to go like this. So it will go down because it starts at the top and goes down through the x-intercepts on each side. This one has x-intercepts because notice that your vertex is above. So since my vertex is higher, it's going to come down through the x-axis. Okay. All right. So I do want to find the y-intercept. That's where x is 0. So 0 is my first value. Again, I just put that in. So y equals negative 1/4. Putting in 0 for everywhere I have an x equals negative 1/4 times 2 times negative 6 equals negative 1/4 times negative 12. So negative 12 divided by negative 4, and be careful because you don't want to mess up your signs. Negative 12 divided by negative 4 is 3. So my x-intercept is 0, 3. One, two, three, right there. Okay, if I mess up my signs and I end up with 0, negative 3, I should be able to tell. If I did that, I should be able to tell there's something wrong probably on that point because that I cannot do that. Okay, I cannot. I cannot do that kind of action. That is not something that's going to happen on this graph. So there's a problem somewhere and most likely on the intercept because the other points look okay. So there it is, 0, 3. That looks good. 2 units over, 3 units up. Okay, there's my matching point. And that looks pretty good to draw my graph. So there's my graph. Okay. Matching point that I did not calculate. 1, 2, 3, 4, 3. Okay, so I didn't calculate it. I'm just saying it's got to be there based on the other points. All right. Okay, so we have 3 other graphs on this set, but this is the basic idea of what we're doing. So we have vertex form, standard form, factored form. For D, probably the easiest way to do this one is do it as a vertex form set. You can also do it standard form, by the way. But if I would do it vertex form, it'd be x squared minus 9. So 1, h is 0 because you're not adding or subtracting anything. And then k is 9, negative 9. So x equals 0 for your axis, 0, negative 9 for your vertex. Y-intercept also 0, negative 9 because of the fact that your vertex and your y-intercept are the same point. And let's see, A is positive, so it goes up. Okay. For the zeros, x squared. Set your equation equal to 0. X squared equals 9. Square root. X equals plus or minus 3. So the square root, once I have a square root, as soon as I take the square root, that's what turns it into plus and minus. Okay, so that right there. So what are my zeros? X equals 3, x equals negative 3, 3, 0, oops, negative 3, 0. All right, so when you're missing some of the parameters, you just need to decide how you want to do it. I could have also chosen to do this one standard form because I could just say bx is b is 0. It'll work out the same way. Okay. So let's see, what were my points? 0, negative 9. I'm doing this one really quite fast. So 0, negative 9, 3, 0, and negative 3, 0, which also makes sense because if my vertex is on the axis, then my x-intercepts need to be centered around the x-axis. So then there's my graph. Okay. So we should hopefully have a pretty good idea of how to graph these. Okay, we've already done a lot of work on that. But the other thing we want to be able to do, we're skipping down to page 4, I think, 3 or 4. I think this is page 3, actually. So we're skipping down to page 3, okay? And what we want to be able to do is if you're looking at a graph, you should also be able to generate an equation for that graph. So this one is asking you to do factored form, okay? So direction of opening is down. That means I know A is negative. Okay, if I'm looking for factored form, I'm looking for my zeros. So on the graph, I identify the x-axis values, the zeros. So what are my zeros? X equals negative 1 and x equals 3. So factored form is essentially these values. So my P is negative 1 and my Q is 3. All right. That means what I know right now is that y equals some A value that I don't know right this minute, x plus 1. Remembering that in your factor, it needs to be opposite. X minus 3. Okay. So zeros back to factors. So essentially your 0 sets and then to factors becomes opposite. All right. So it has to undo it because you have to undo the 0 value. Okay. All right. Obviously, we're almost done, except we need this A value that we don't know. Okay. In order to generate another value, so we've already found 2 points on this graph. The points we've found are negative 1, 0 and 3, 0. In order to finalize this, you have to get one more point that's a good point. So I'm going to choose this point up here. That looks like the vertex point, but also looks like it's nicely on a corner. So I can see that it looks like that point is an exact value of 1, 4. So here I have the point 1, 4, and this is an XY point, okay? So into my equation that I'm creating, I need to feed that point because right now what I essentially have is I have X, which is a variable. I have Y, which is a variable. And I also have A, which is another variable. So I need to find A. A is a specific set number because this is a specific graph, okay? So in order to do that, you need a point that's on this graph. So in other words, this point solves the graph. So this point has to solve the equation. So I basically just put it in. And be careful for where you're doing it. So basically it's going to be 4. And A is what I don't know. Okay, and X is 1. So note that when you're kind of doing it, one of the things you might want to be paying attention to is these kind of look like they switch. So the first number goes second and the second number goes first because of how we set it up. So X is what we put in, right? And then this is your answer. So basically when you're setting it up as an equation, your answer is out in front. So just be careful how you're putting it in. Okay, just take a second, make sure your X's and your Y's are in the correct places. Once I have this, I just need to evaluate it. Okay, A, and then 1 plus 1 is 2, and 1 minus 3 is -2. And then what I want to do with this right here, once I've figured this out, I want to put in the front. Because we are very used to seeing this number should be calculated and put basically here, all right? So what I'm going to get is 4 equals -4a, because I want to be careful because it's a multiple, not an addition subtraction. Then divide both sides by -4. So what did I find for a? A is actually -1. So what is my actual equation? Y equals negative x plus 1, x minus 3. And that is my actual final answer, okay? Finding the actual a value. So you have to do a point calculations. Once you have the formula, you need to put it in as a point calculation in order to find your final value. So that's finding it as a factored set, okay? Essentially zeros to factors, and what? Then you find a point, then you plug it in, okay? And then that gives you A. So, and that looks good because I already know A has to be negative and A is actually -1. So notice that A gets filled in last, all right? All right, so let's look at another one. This one's asking me specifically for vertex form. So vertex form is of the form, can erase that right there, I need a little more room. Vertex form is of the form y equals a x minus h squared plus k, where hk is my vertex. So I look at this point, I see that point is 3, -2. That means that is my h and that is my k. So I find the vertex and that is my hk point. So this one's actually really easy as far as identifying the first part of the values, because basically h is now 3 and k is now -2. What is my vertex? 3, -2. What is that point? My hk point. I can see that my graph is going up. Over here, what I know so far is a is positive, okay? What I know about my equation so far is that I don't know a. I do know x minus 3 squared minus 2. Note that h is +3, so when I put it in, it comes in opposite. So +3 up here, -3 in the equation. Again, anything inside parentheses is opposite. So wherever you put it, you pull it out, it becomes opposite. You put it in, it becomes opposite, okay? Same idea as last time, you need one more point. I'm going to choose this point here. you kind of have two choices, but I'm going to choose that one. So that point is 4, 0. So I have an XY point of 4, 0 that I found by looking at my graph, and then I put it in. So 0 equals my A value, and then my X value is 4. Okay, and notice once again that essentially it kind of looks like it's switched. So there's my Y value, it goes in for the Y in the front. There's my X value, goes in for X. So just take a second here, be careful and make sure you're putting the X's for the X's and the Y's for the Y's. Okay, so 0 equals A. 4 minus 3 is 1. That is 1 squared. That's 1. I'm going to put that in front. So 1A. So always put your number in front. Okay. So notice this number here turns into this number in front. Okay. Be careful because the most common error here is you do 1 minus 2 because they look like, what happens is these two look like they're together, but they're really not, because really that's a multiplier. Okay, standard set is regular number multipliers go in front of the variables, but then this already was a variable, so it's a leading variable. So just be careful with that, and whatever you're doing with it, put it in the front. Okay, so evaluate and put it in the front. So now I'm just basically solving. So now if I look at what I'm basically solving, I'm pretty much solving A minus 2 equals 0. So add the 2, and what I end up with is A is 2. Okay, so my final equation is Y equals, A is now the actual value of 2, so I found that parameter, X minus 3 squared minus 2. Okay. I think generally vertex form is probably the easiest one to finalize because the vertex is simple. All right. So that's that one. All right. So if we're doing standard form, all right, where are we? So if we're doing standard form, okay, notice that what we're starting with is factored form, and then we find standard form. You cannot find standard form directly, generally, okay? So you start with your factored form to get to standard form. So up, zeros are here at -5, and here at -1, -1. So my P value is -5, and my Q value is -1. By the way, you could also just do this if you prefer it. You could also do vertex form and go from there. I mean, because there is the vertex right there. A, I don't know. Okay. I do know that I have Y equals A times X plus 5, X plus 1. All right. Find a second point right there. I'm going to use that point as the vertex. -3, -4, and I'm going to put it in. So -4 equals A what am I doing? -3 plus 5 and -3 plus 1. So what have I done so far is I have essentially just calculated that, right? So what am I getting then? equals A. That's 2 and negative 2. So that turns into negative 4A. So what I get is negative 4 equals negative 4A. Okay, again, I took this multiplier and I put it in front. Okay, dividing by negative 4, A is 1. All right, so A is 1, so my equation in factor form, x plus 5, x plus 1. Plus 1. Goodness gracious. That's horrible. How do you get standard form? You take it and you multiply it. Wait, it's not 1, it's 5, I think. 5, yeah. So you basically, to get your standard form, you distribute, all right? That's it for today, guys. Thanks. That was the bell. So see you Tuesday, I guess. Have a great day, okay?
Thank you.
Thank you.
See ya.
See ya.
Thank you.